College Algebra Chapter 11, Section 2, Arithmetic Sequences and Series. A sequence in which each term after the first is obtained by adding a fixed number to the previous term is called an arithmetic sequence or an arithmetic progression. So arithmetic involves adding. The fixed number that is added is called the common difference. 5, 9, 13, 17, and so forth is an example of one, because to get each term, you're going to add 4 to the one before it, and 4 would be the common difference. So find the common difference for this sequence. Pause the recording, give it a try, and resume to check your answer. You can find the difference by subtracting any two of the consecutive terms, and subtracting the first from the second, we find that 2 is the common difference. In other words, to get from one term to the next, you're going to add 2. Here's another example. Write the first 5 terms of each sequence. Pause the recording, give it a try, and resume to check your answer. Our common difference is -3, and you have the first 5 terms outlined there. For B, we have a common difference of 5, and you see the first 5 terms there. If a sub 1 is the first term of an arithmetic sequence, and d is the common difference, then the terms are a sub 1 plus d, a sub 2 plus d, but then remember, a sub 2 was a sub 1 plus d. So we really have a sub 1 plus 2d. And then continue the same pattern, and you'll notice really to get down the series, down the sequence, we really don't need to know every single term. We just need to know which term it is, and that kind of helps us. If we know the first term and the term we're after, we can actually, and the common difference, we can jump straight to that. So a sub n, any term you want, the nth term, is a sub 1 plus n minus 1, the number of terms minus 1 times the common difference. Here's our little theorem or definition that says that in an arithmetic sequence, the first term a sub 1 and the common difference is d. The nth term is a sub 1 plus n minus 1 times d. Okay, use that rule to find the 13th and the nth term for this sequence. We know what a sub 1 is, and you can find the common difference, then use the formula. Pause the recording, give it a try, and resume to check your answer. All right, so we know a sub 1 is -3 and d is 4. And for 13, we're going to have a sub 1 times n minus 1 plus d. In other words, a sub 13 is -3 plus 13 minus 1 times 4, which is 45. The a sub nth term, we don't really have a number to put in there. Except for the first one and the common difference, we put those in, and then we just kind of combine like terms and distribute and all that stuff and get an expression. So a sub n is 4n minus 7. Now try this example. Pause the recording, give it a try, and resume to check your answer. Okay, we were able to figure out the common difference, and when we know the common difference, we can backtrack to find a sub 1. So a sub 1 is 3, and the common difference is 6. Putting it into the formula, the 18th term is 105, and the nth term is 6n minus 3. Here's another example. This time you know the 8th and the 16th term, and you need to find the first. So think about it, pause the recording, give it a try, and resume to check your answer. Okay, we know that to get from the 8th term to the 16th, you will have had to add the common difference 8 times. So you're adding 8d. We know the 16th and the 8th term, so we'll put in those values and we'll solve for d. And when we solve for d, we get that d is -3. So now we know. We can use the equation a sub 8 equals a sub 1 plus 7d, which is our formula for the nth term. But this time we're missing a sub 1. We'll substitute the numbers in for a sub 8 and for d, and we get that a sub 1 is 5. The points on the graph of an arithmetic sequence f are defined by f of n equals dn plus c, where n is a natural number. So the points must lie on the line y equals dx plus c. You've got to put in the x and y because that's what we have, our axes are x and y. Notice that this looks a lot like y equals mx plus b, which means that d, the difference, is actually the slope. Also note that this is a linear equation. The points must be collinear. They must line up. Otherwise, we have no arithmetic sequence. So first of all, remember, we're not connecting the dots. And secondly, if you graph it and it looks like the second graph here where it's not lining up, then you have no common difference and it is not arithmetic. Now we're going to find the formula for the nth term of the sequence that's graphed to the right. Now remember, if you can figure out the y equals mx plus b equation, you know the common difference. Pause the recording, think about this, give it a try, and resume to check your answer. Okay, the equation of the line of the points, the line that the points form, is y equals negative 0.5x plus 4. Y plus 4. Well, if you backtrack the line one more step to where x is 0, you're going to get y. So that's your y-intercept, even though we don't have a point there. And the slope, we're going down 1/2 and over 1, so negative 1/2. So the sequence, the equation is y equals negative 0.5x plus 4. The sequence, writing it in sequence notation, is a sub n equals negative 0.5n plus 4. And we need to specify our domain. Our domain goes from 1 through 6. So n equals 1, 2, 3, 4, 5, and 6. Okay, now we're going to talk about the arithmetic series. The sum of the first n terms of an arithmetic sequence is given by the formula you see here. It says if an arithmetic sequence has first term a1 and common difference d, the sum of the first n terms is given by the following. And we actually have two little formulas here. You can use whichever is appropriate. If you know the first and the last term and how many terms you've got, the first one is easy to use. If you don't know the last term, but you know how many terms there are, then you can use the second formula, which kind of combines this formula, the formula on the left, with the formula for finding the nth term. So you've got two formulas there that you can use, depending on the information you're given. So use the formula to find the sum of the first 60 positive integers. Pause the recording, give it a try, and resume to check your answer. Okay, so the sequence is 1 through 60. A sub 1 is 1, and A sub 60 is 60, so we actually know the value at the end. The sum is 60 over 2 times 1 plus 60, which is 30 times 61, which is 1830. In this example, we know the sum of the first 17 terms. That sum is 187. They're giving us A sub 17, which is negative 13, and we're supposed to find A sub 1 and D. All right, think about this. Pause the recording, look at your formulas, decide which is going to be the best. Resume to check your answer. All right, so first we have the formula, and we've substituted in the values that we know. We have 17 over 2 because it's 17 numbers. We have A sub 1 plus A sub 17. And we know that A sub 17 is negative 13, so in the second line we put that in. And we also know the sum is 187, so we're going to put that in. And then we're going to solve for A sub 1. And so we do a little algebra, and we get A sub 1 is 35. Now we're going to use this information to find D, and we're using the formula that we used earlier. We've got A sub 17. We already know what that is. That's negative 13. We just discovered A sub 1 is 35, and we know that n equals 17, so 17 minus 1 is 16, and solve for D, we get negative 3. All right, now evaluate this sum. Remember how to write this. The idea is that you're going to replace I with the numbers from 1 to 10 in this formula. Pause the recording, give it a try, and resume to check your answer. Okay, the sum contains the term of an arithmetic sequence. We know that a sub 1 is 4 times 1 plus 8, which is 12. We can figure out the 10th term by putting 10 in for I, which is 48, and then using our formula, 10 over 2 times 12 plus 48 gives us 300. The rest of this is extra practice, so pause the recording as you go through these, try them out, then resume to check your answers. Do this through the rest of the recording.